Dear students, today we will learn about factors affecting in vitro secondary metabolite production. Let us start with the introduction. Plant secondary metabolites are produced by plants in small quantities and play major role in plant defense. In addition, they are used as pigments, dyes, insecticides, cosmetics, perfumes, nutraceuticals, pharmaceuticals, and as food additives in the form of flavors, fragrances, or colorants. However, the production of these secondary metabolites depends on several factors like plant genotype, physiological and developmental stage of the plant, environmental effects, variations in crop quality, adulteration and losses in storage and handling, etc. Moreover, the dependence on plant natural resources for these metabolites has resulted in rapid loss of population of the important plants from their natural habitats. Further, the chemical synthesis of these secondary metabolites is also difficult and economically not feasible, since these secondary metabolites have highly complex structures and specific stereochemical characteristics. In such a situation, plant cells, tissues and organs cultured in vitro represent an alternative potential source for production of plant secondary metabolites. Different in vitro culture systems such as callus cultures, cell suspension cultures and organ cultures are used for in vitro secondary metabolite production. Since the undifferentiated plant cell culture systems have been found to produce lower amount of the metabolites compared to the mature intact plant organs, different strategies have been adopted to improve the production of secondary metabolites by plant cell cultures. Moreover, since plant cell cultures can be scaled up for large-scale culturing, plant tissue cultures may provide a continuous and reliable source of secondary metabolites. Let us now see the advantages of using plant cell cultures for secondary metabolite production. The major advantages of using cell cultures for secondary metabolite production includes: first, secondary metabolites production by plant cell cultures is carried out in controlled environments and is independent of environmental, geographical and seasonal factors that affect secondary metabolites production in plants under natural condition. Secondly, the production of secondary metabolites takes place in defined systems, which allows continuous supply of products with uniform quality and yield. Next, cultivars with higher secondary metabolites production can be selected for initiation of cultures, and further, cell lines with higher production potential of secondary metabolites can be screened and selected. Next, since plant cells can carry out stereo and regio-specific biotransformations, they can be used as sources for the production of novel compounds that are not normally found in parent plant. Next, plant cell culture systems allow efficient downstream processing of the products. Finally, cell growth control and regulation of metabolic processes can be automated, which will lead to increase in production and decrease in cost price. Next, let us see the disadvantages of using plant cell cultures for secondary metabolite production. The major disadvantages of using cell cultures for secondary metabolite production are as follows. First, unlike microbial cultures which are suitable for industrial production of useful products, plant cell culture systems has many biological problems including genetic instability, physiological heterogeneity, slow growth rate, product secretion, low metabolite content, etc., which affect the secondary metabolite production potential of the cell cultures. In addition, many operational problems of large-scale plant cell culture systems like light requirement, mixing, wall adhesion, shear sensitivity, aseptic condition, etc. limits the production of secondary metabolites. Due to large size of plant cells have high doubling time and it leads to elongation of the time required for successful fermentation run. Moreover, compared to the high-yielding microorganism cultures that secretes the metabolites in the medium, plant cells commonly do not secrete the metabolites and are usually accumulated in the vacuoles. This is another hurdle in plant secondary metabolite production in vitro. Next, we will see the strategies for increasing secondary metabolite production by plant cell cultures. Different strategies can be applied to increase the production of secondary metabolites by plant cell and tissue cultures. Maximization of product accumulation can be achieved by applying the following strategies. The first one is selection of high secondary metabolite yielding parent plant. This is the initial step where explants derived from a parent plant with high content of the desired metabolite are used for callus induction in vitro. Next is the selection of high yielding cell clones. After establishment of rapidly growing in vitro cultures with high secondary metabolite content, the cell lines that accumulate high amounts of the metabolite can be selected for further multiplication and production of the metabolite. New high-yielding cell lines can also be selected from mutant cell lines obtained by treating with mutagens and from new genotypes obtained by fusing protoplasts or through genetic engineering. Next strategy is the targeting metabolism by manipulating the composition of growth media. Secondary metabolite production in plants is affected by many physical and chemical factors, and accumulation of secondary metabolites in plant cell cultures is also influenced by many environmental conditions, including the chemical composition of the medium as well as the physical conditions of the cultures. Plant cell culture medium commonly contains inorganic salts, organics and phytohormones. Changing the concentration, proportion and form of these components has been shown to enhance the production of secondary metabolites by cell cultures. The next strategy is the manipulation of environment parameters. A number of physical conditions like light, temperature and medium pH, aeration, agitation, etc. also affects the secondary metabolite accumulation in many plant cell culture types. Manipulation of these parameters in plant cell cultures is an important fundamental approach for optimization of culture productivity. Next is precursor feeding. It involves the exogenous supply of compounds which are intermediate or appear at the beginning of the biosynthetic route of the desired secondary metabolite by adding to the culture medium. The concept is based on the idea that feeding the cultures with the intermediate compounds and precursors may increase the yield of the final product or metabolite. Next is elicitation. Elicitors are signals that trigger the formation of secondary metabolites as part of plant defense mechanism. Elicitation is the process of induction or enhancement of secondary metabolite synthesis by applying unfavorable environmental changes that simulate pathogen attack, herbivores attack, heavy metals, etc. In vitro plant cells also show physiological and morphological responses to microbial, physical or chemical elicitors which induces the synthesis of secondary metabolites. Different biotic and abiotic elicitors which are classified based on their origin have been used as an effective strategy to enhance secondary metabolite production in plant cell cultures. The next strategy is biotransformation. Biotransformation is the transformation of functional groups of exogenously supplied simple precursor compounds by plant cell cultures to produce chemically different product involving reactions like hydrogenation, dehydrogenation, isomerization, glycosylation, hydroxylation, etc. Biotransformation using exogenous supply of precursors may lead to the improvement in the production of the metabolites whose synthesis in cell cultures is often limited by the lack of particular precursors. The next strategy is cell immobilization. Cell immobilization is the entrapment of cells in a gel matrix while allowing easy access of substrates. The gel matrix is commonly made up of hydrocolloidal gels such as alginate and carrageenan. Immobilization of cells offers certain advantages like high concentration of plant cells that can be used in bioreactors, protection of sensitive cell lines from shear stress and enhanced product formation as the cells can be maintained for long duration. However, cell immobilization technique is associated with limitations like difficulty in mass transfer of nutrients and metabolites. Next is the hairy root culture. Hairy roots are rapidly growing, highly branched roots with plexiotrophic growth which are induced by infection with Agrobacterium rhizogenes and can be maintained on phytohormone-free medium. Hairy roots have been studied extensively for secondary metabolite production and they have been found to produce plant secondary metabolites over successive generations without losing genetic or biosynthetic stability. The next is the two-stage system for spontaneous release into medium. Plant secondary metabolites are often synthesized and stored in separate cells or organs and are commonly accumulated in the vacuoles, which inhibits the release of products into the medium. This is a limitation for efficient bioprocessing since it prevents the spontaneous release of phytochemicals into the medium. One alternative method to eliminate the vacuolar accumulation and enhancement of product release into the medium is to allow the accumulation of the secondary metabolites in another phase introduced into the aqueous medium of the culture known as the two-stage system. Let us now see the conclusion. Plant cell and tissue cultures can be considered as a potential source for the production of important secondary metabolites. Since the production of secondary metabolites by plant cell cultures is independent of environmental conditions and quality fluctuations, fast-growing and high metabolite producing cell lines can be established by adopting certain strategies like selection of parent plants, supplying precursors, application of elicitors, and by special treatments such as biotransformation and immobilization, etc. Thus, the application of these strategies can help in exploiting the potential of plant cell cultures as the sources of secondary metabolites. Thank you.